Hi everybody. Just to set the context of the session. Okay. So I think last we were discussing inheritance. Okay. And in inheritance, we have seen what are the different types of inheritance. That is single inheritance and single or simple inheritance. Then multi-level inheritance. In case of multi-level inheritance, a derived class acts as a base class of some other class. Then we have seen multiple inheritance in which there is a common derived class. Okay, fine. So similarly, we have hierarchical inheritance. I think we are yet to see the example for hierarchical inheritance. So after hierarchical inheritance, we can just take a look at hybrid inheritance. Okay. So what is hierarchical inheritance means? In hierarchical inheritance, there is a common base class, okay, and there can be multiple derived class, okay. So it is just like a, okay, a hierarchy in the organization, okay. So, for example, there is a director, and managers, multiple managers report to the same director, and there are multiple leads who report to a single manager, okay. So So let me just show the diagram for that. So it looks something like this. Okay. So A is the base class, common base class for B and C. For D and E, B is the common base class. Okay. And for these three classes, this is the base class. Okay. So here we have three levels. So it does not mean that we need to have three levels. Even it is fine with A, B, C. Okay. There is a hierarchical inheritance between A, B, C. Okay. So let us just take a look at the code example. Okay. So where do we have uh, hierarchical inheritance? Yeah, we have it here. Okay. So let me remove this. Okay. Then, right. So let me just try to explain this. Okay. Looks like the example, this example is slightly complex. We are using array of objects. Okay. So that is fine. So I'll just try to brief this to you. Okay. So here we have a base class. Okay. The base class is person. Okay. And we have uh, the data, also data members associated with the person class. Okay. And we have a couple of methods, okay, public methods, okay. So as seen here, okay, there is no access specifier. So the default access specifier in C++ is private, okay, right. So here we have a class employee, okay, which is derived from person class, okay, right, and it is being derived privately. So hierarchical inheritance does not talk about whether we need to inherit privately, publicly, or protected, but it says there is a common base class. Okay. So here if you see, person class is the base class. Okay. And here as well, person class is the base class. Okay. Right. So here there is a common base class, and hence this is an example for hierarchical inheritance. Okay, so let us just take a look at the code. Okay, right. So here, employee, there are employee specific details. Person means person specific details. We have name, description, and those details. Okay, so here we have employee specific details like what is the salary, HRA, PF, etc., etc. Okay, fine. And here we are displaying the details of only employee. Okay, right. If you go, okay, to the person class, here we are displaying the details only about person. Okay, right, right. And if you closely observe here, this in turn calls the derived class method, which is person display. Okay, and if you see closely here, this is invoking the base class method get person details. Okay, right. So as already known, so all the members of the base class are available here, okay, and it can be directly accessed except private members of the base class, okay, right. So here get person class is not a private, it's public, okay, right. So it is inherited here. Here it is, since we have inherited using private inheritance, okay, so here get person details is available as private, okay. However, it can be accessed by the method in this class itself, okay, right, fine. So here, yeah, we are specifying the details of the student, okay, maybe which course and college, okay, right. So if you observe closely here, see in most of the examples we are seeing array for the base classes and derived classes or array of objects. So it doesn't mean that we need to always use arrays for base class and derived classes, okay, right. It depends upon the requirement, okay, fine. So student, we are creating array of objects, okay. For employee, we are creating array of objects, okay. So here we are asking to enter the number of students, okay, uh, right. So once we take in, we are just trying to get all the details by iterating through, okay. And one more point here is, since we have hard coded the value 10, okay, right. So there is a limitation that the number of students cannot be more than 10, okay. It should be less than 10, okay, right. Next, fine. So here we are just iterating and we are getting the values, we are invoking, okay. So this is an object of the student, okay. So the object gets created here. The constructor of the student gets invoked 10 times, the default constructor, okay, right. So for each object we are setting the values here, okay, by invoking get student details. That will further invoke get person details, as we had seen a few minutes back, okay, right. So here we are trying to display the student details, and here we are trying to get the employee details, okay, and further we are displaying the details of employee, okay. So this is an example for hierarchical inheritance. In this hierarchical inheritance, we can see that person is a common base class between student for student and employee, okay. So it doesn't mean that there should be only two derived classes, there can be multiple derived classes. The only thing is there need to be a common base class, okay, right, fine. So let us just try to execute it, okay. So the example is hierarchical inheritance. Yeah, I think it's not at moved. So okay. So here we have, let me remove this object file. Okay. Right. Otherwise it causes linker error saying there are multiple main methods. Okay. All right. So let us execute it. So it's building. Uh, okay. There is a warning. So for PolyTX hierarchical inheritance and multiple inheritance. Okay. So just trying to rebuild. Fine. So, okay. So enter the number of student. I'll just enter 2. So enter person details. I'll just put it as A. Okay. Oh, fine. Looks like, okay. So there is some problem in this uh, taking the input. Okay. Sorry. The first it is asking person number. Okay. All right. So let me just try to close it and let me execute it once again. Okay. Enter the number of students. I'll just enter as 2 students. Enter the person number. I'll put it as 1. Enter the person name. I'll just put it as A. Enter the person designation. I'll just put it as head. Okay. Enter student college name. I'll say ABCD college. Enter course name. I'll say QRST. Okay. So enter the person number. Okay. Fine. 2. Right. So it goes so on. Okay. So basically here uh, we are using this as an example for hierarchical inheritance. Okay. Fine. Let us move on with the other topic. I'll be sharing the examples. Maybe you can try to make some changes here. Okay. Right. So I just want to add some details here. Okay. How we can make this program uh, more flexible. Okay. So one of the thing which I can think is, here we are hard coding the values as 10. Okay. So let us assume I have a necessity um, such that the requirement is the number of students varies, like it can be 5 or it can be 100, it can be 200. So that time, okay. So as per the current solution, we need to give the maximum numbers here. Okay. Right. So let us assume we want to decide the values dynamically in the runtime. Then what we can do is, we can try to make it as a pointer, and we can try to uh, okay, we can try to dynamically allocate that many elements. Okay. Fine, by using a new keyboard. Okay, in the runtime. Fine. Okay. Fine, let us move on with the next topic. Okay. Right. So we already know that the order of invocation of the constructors and destructors. Of course, in the last hierarchical inheritance, we didn't use any constructors. Okay, but if there is a need to initialize the object appropriately, we may need to use constructors. Okay, so as already known, whenever you create the object of a derived class, first the basemost class constructor gets invoked, and eventually like all the constructors of the derived, the next level derived, etc. Okay. Right. So that is the order of execution of constructor. And the order of destruction, execution of destructors is the just opposite order of creation of the sorry, it's just the opposite order of execution of constructors. Okay. Right. So here if you see this, okay, here what happens is, first the constructor of A gets called, then the constructor of B gets called, then the constructor of C gets called. Okay. This is the case when you are trying to create the object of class C. Okay. Right. So here in multiple inheritance, it follows the order in which they appear. Okay. Right. In this statement. Okay. Right. Fine. So now it's time to discuss what is hybrid inheritance. Okay. See, an hybrid inheritance is nothing but which has multiple inheritance, sorry, different types of inheritance. Okay. At least couple of inheritance, excluding single inheritance. So here if you see, okay, between A, B, and C, we know that we have a hierarchical inheritance. And between B, C, and D, we know that there is between B, C, and D, there is uh, multiple inheritance. And if you see between A, B, and D, or A, C, and D, okay, separately, we know that it is multi-level inheritance. Okay, right, fine. So whenever, okay, whenever we see, like, see, this is called the diamond relationship. Whenever you create a similar type of hierarchy, okay, like a similar type of relationship between the classes, okay, so it is recommended to use, okay, we need to inherit it virtually. Okay, so this is called virtual inheritance. The reason is, so here B and C both gets the content of A. Okay. And when you try to get into the D, both the contents of A are available. One copy is available in B and one copy is available in A. And both of them, okay, uh, right, so will be available to D. And hence, to avoid that, okay, so we need to use virtual inheritance. It is not that if you want to use hybrid inheritance, you have to use virtual inheritance. But whenever you see a diamond kind of a relationship like this, okay, uh, right, so right, we need to use virtual inheritance. Okay, so however, multiple inheritance is not supported in Java. Okay, so because of diamond problem and other things. However, in C++, we are free to use multiple inheritance. Okay, right, fine. So right, fine. Here we have an example for multiple inheritance. Okay, right. So there is a class student and there is a class ports. I think we have already seen this yesterday. Sorry, in the previous session. Okay, so here we have a statement, and we are trying to inherit from both student and sports. Okay, if you want, you can put a constructor in statement student sports and just try to observe the order of execution of constructors. Okay, right, fine. Now, okay, so whenever we have a base class and a derived class. Okay. One thing what we need to remember is the derived class object is of type base class also. Okay. Right. Say for example, here we have C polygon. Okay. And we have C rectangle. Okay. Right. So the object of C rectangle is obviously of type C rectangle, which we already know. What I'm trying to tell now is the object of C rectangle is also of type C polygon. Okay, right, right. So let us see more related details in this example. See here I have base class with the name C polygon. Okay, and here we have the derived class C rectangle. Okay, and we have one more class C triangle. Okay, right. So here I'm creating an object of C rectangle, it's known. Here I'm trying to create an object of uh, C triangle. So basically, right, if you try to summarize, C polygon is the base class of both of them, C rectangle and C triangle. And since there is a common base class, it is hierarchical inheritance. Okay, right, that's it. That's a different point. Okay, right. So here I am declaring a pointer to a class, okay, of type pointer to an object of type C polygon. Okay, fine. So here also I'm declaring a pointer of type C polygon. So what I was trying to tell is this can very much point to objects of any of the derived classes. Okay, so here we are pointing to a rectangle, here we are pointing to the triangle. Okay, right. Of course, here we have created that in a stack and we are assigning to this. If required, you can try to dynamically create it using new keyword and invoke the constructor of the corresponding derived classes here. Okay, right. And one more thing is, see, whenever we have a pointer, okay, and you want to access the methods inside that object, okay, so we need to use this arrow operator. Okay, we know that if it is a normal objects like this, we use dot, but for this we need to use arrow. Okay, fine. So here we are just setting the value of, okay, 4 5, set value is 4 5. Okay, right. And right, of course, since it is the same objects, okay, since it is the same objects, like p poly 1 is pointing to an object and rect also is the same object. Okay, so we are just trying to invoke rect and triangle. Okay, so basically we are just trying to show here that the base, the derived class object can be pointed by a base class pointer. Okay, all right. So let us try to execute it. Okay, so let us try to execute it. I think we are not taking any input from the keyboard for this. Okay, okay. So fine. So here the area method of rectangle is invoked. Area method of triangle is invoked. Okay, right. Okay, right. Okay, fine. Let us move on to the next topic. Okay. See, one of the powerful feature of this inheritance is runtime polymorphism or virtual functions. Okay, I'm not talking about virtual classes. Okay, I'm talking about virtual functions. Okay, right. So, what is the advantage of it? Okay, means uh, right. So, let us take a look at the presentation and let's come back here. Okay, right. Okay, it is also called function overriding. It is called runtime polymorphism, virtual functions, or also function overriding. See, until now in the base class, we have some methods and data associated. And in the derived class, whenever we know that the same methods and the data members, provided those are non-private, are available in the derived class also. Fine. But let us assume I have a method ABCD in the base class, and I have another method ABCD with the same declaration in the derived class. Okay. So in that case, what happens? Okay. So the overriding happens. So let us see what are the main requirements for overriding. Okay. Right. So number one requirement is function with same name and same parameters and same return type. So basically, We need to have two functions with the same declaration in the base class and in the derived class. Okay, right. So that need to be defined in the base class and derived class. Okay, when derived class object calls the function, it calls overridden function in the derived class. Okay, when base class object calls the function, it calls the base class copy of the function. Okay, so based on the need, okay, it is possible to switch between base class, okay, implementation of the method or derived class implementation of the method, right? So let us see an example for that. Okay, okay. So here we have a base class. Okay, there is a display method. There is a derived class. There is a display method. It need to be D, and here also it should need to be small d. Okay, right, right. The declaration need to be same in the base class and in the derived class, also method. Okay, which you want to override. So here we created an object of D, and we are invoking display. Here we are creating an object of D, and we are invoking. Okay, so here the overriding, okay, happens. Right. Fine. So, okay, all right. But this is not the real complete override. Okay. For a overriding to occur, okay, we need to use virtual function. Okay, right. So that is not the complete information. Okay. So basically, in virtual function or runtime polymorphism, in the runtime, it should be possible to switch between multiple implementations. Okay, right. See, the member function preceded by the keyword virtual in base class and overridden in the derived class. So basically, if you want a base class method need to be overridden, you need to specify virtual keyword. Okay. So if the object of the base class invokes virtual function, if the object of the base class object of the, okay, then the copy of base class invoke, and if derived class object invokes it, then the copy of the derived class is invoked. Okay, so see virtual functions, in case of virtual functions, which function need to be executed, okay, is decided in the runtime, not during compile time. Okay, right. So what is the advantage, we will see in few minutes. Okay, right. Okay, so let us see an example, okay, so that we can understand better. Okay, fine. Right. So if you observe closely, I have a base class, okay, and we made this as virtual, okay, right. So without virtual keyword for a function, for a method, it cannot participate in, okay, a runtime polymorphism, okay, right. Here in the derived class, we have the uh, display method and we have the show method, but okay, right, we have both the methods. See here, we are creating a pointer of type base class, okay, and here we already know that this pointer p can point either to base class object or derived class object. So what I want to tell is, whenever this P is pointing to base class object, okay, then, okay, the base class method gets invoked, okay, provided it is virtual, okay, right. If this P is pointing to the derived class object, then, okay, the overridden method, uh, okay, right, the overridden method of the derived class gets invoked. Okay. See, here we have two methods. One is display show. Okay, display show. In this case, what I want to emphasize is only the show method, okay, participates in runtime polymorphism, but not display method. Okay. So let us just try to run it. Right. So let's make some code changes to make it compatible with the latest version of C++ compiler. Okay, right. So fine. So as already told, to execute programs, you may set up you can use Turbo C++ editor. Here I'm using Eclipse, and you can use IDE1.com. Okay, you need not set up anything. You just need internet connection. You can just go type the program there and, okay, execute it. Fine. So there is a CLR, ICR, but I removed the corresponding header file. Okay. So let us execute it, build it once again. Okay. So right. So if you observe closely, see here the base class display and base class display. Basically, here if you see it is base class show, here it is derived class show. So the show method is participating in runtime polymorphism. Okay, right? Because it is virtual. This is not virtual. Okay, that's why it doesn't participate in runtime polymorphism. Okay, runtime polymorphism is a very powerful concept. Okay, it helps us to write the to give some plugins dynamically and to execute, because which method need to get executed is decided in the runtime, not during compile time. Okay, so you can write a software in which you can create the derived class objects as a separate plugin, and you can try to add that object file or library files. Okay, and you can use the same base class pointer, and you need not know the derived class name or anything. Okay, so we can use the base class pointer. Okay, and we can have some register method which supplies the derived class object, but okay, but it can be pointed by this. Okay, so basically what I'm trying to emphasize is it is possible to shift between different methods. Okay, which method need to be executed is decided in the runtime, not during compile time. Okay, this is very important concept. Okay, fine. Next, Okay, so to give the real life example, like where this is applied, see, I'll give one very good example. Say for example, we have Windows operating system. Okay, so we all know that there can be multiple themes, and you can select the theme whichever you want in the runtime. Okay, that means you can select a theme and you can see that like, your screen get changed to the theme, and then again you change the theme, again it gets changed. The reason is it is a runtime thing, so it is so runtime polymorphism is applied there. Okay, if it was a comparative polymorphism, then what had to happen is you had to rebuild the entire operating system if you want to change it. Okay, if you want to change the theme. Okay, so runtime polymorphism is that powerful. Okay, right. And one more advantage is, let us assume you have 3 or 4 themes on Windows. It is possible that you add a fifth theme or sixth theme, and you can try to install fifth or sixth theme, and it is possible to pick that fifth or sixth without rebuilding the entire operating system or whichever. Okay, so that is the real advantage of, okay, uh, runtime polymorphism or runtime binding. Okay, it is also called as late binding. Okay, right. In case we didn't have that, okay, so okay, so end user wouldn't have that comfort of selecting the themes in the runtime. Okay, fine. And there may not be comfort of adding new themes. Okay, installing new themes. Okay, without making any code changes to the underlying framework or the operating Windows operating system. Okay, right. So similarly, this runtime polymorphism is applied in a number of situations. It is very very powerful concept. Okay, right. So it is called runtime polymorphism. Method overloading is called compile time polymorphism. So compile time polymorphism is not very powerful. Okay, right, fine. So now we have, okay, idea on runtime polymorphism. Okay, so we know what is inheritance, we know what is base class, what is derived class, different types of inheritance, and we know what is method overriding or runtime polymorphism. Okay, now let us discuss one more concept, which is, okay, so please go through this, please go through this, okay, of course I have provided the examples in the snippet which will be shared with you. Okay, right. And please read all these points point to point and analyze it. Okay, right. So these concepts like polymorphism, all these, okay, method overloading, and all these are not specific to C++. Okay, it's available in Java, it's available in C Sharp, it's available in Python. Okay, any language. Okay, so when you get the deep insight of these concepts, okay, so it will help you to learn any other languages easily. Okay, right, fine. Next, one more thing is, see, there is something called pure virtual function. Okay, see, if you go to the previous example and see, as you can see here, I have a show method. Okay, in the base class, I have a show method in the derived class. Everything is fine. But let us assume because of whatever reason, I didn't have the implementation of show in the base class. Okay, right? Okay, so it is like this. Okay, so this is called pure virtual function. Okay, that is called pure virtual function. Okay, so as we know, the pure virtual function, since it exists, there is no body there for the function, then definitely the class is incomplete. Since it is not complete, it is not fully cooked, you cannot create an object of base class. Of course, you can use it as a pointer, but not as a object. Okay, because it's not fully complete, right? So such class is called abstract class. Okay, so an abstract class is the class which cannot be instantiated. Okay, that means we cannot create an object of uh, abstract class. Okay, fine. Okay, so I think we have some other example. Looks like no. Fine. In that case, we can pick the same example and make changes so that we can see we can see the behavior of pure virtual function. Okay, right. So as specified here, virtual member function of base class without definition and forces the derived class to give it for the definition. So in a pure virtual function, the base class does not have the definition for that method. So who gives it means it is the responsibility of the derived class to give the uh, okay, to give the body or the definition for that method. By any chance, if the immediate derived class is not doing, it is the responsibility of the subsequent derived classes to provide the method body. Okay, so which all methods are not providing body for that, those are considered as abstract. Okay, in the chain of hierarchy, in the chain of inheritance. Okay, and definitely we cannot create an instance for that. Okay, right. So if a derived class fails to provide definition for the function, then it becomes an abstract class and instance of it cannot be created. Okay, so I was just trying to explain the same thing. Okay, right. So if you try to pictorially understand it, okay, say for example, here you have class A. Let us assume this is a abstract class. Okay, since maybe one or more methods are pure virtual functions. Okay, say this as B is derived from A, and for whatever reason B is not providing methods for one or more virtual methods of A. Okay, then one or more pure virtual methods of A, then it is the responsibility of the next derived class. If not, then it's the responsibility of the next derived class. Okay, so whichever are not implementing all those pure virtual methods in this chain, okay, all those definitely are abstract classes, and definitely they cannot be instantiated. Okay, right, fine. So abstract class says we need to have at least one pure virtual function. Okay, so the object of object abstract class cannot be created because it contains one or more pure virtual functions. That is the functions without definition. Okay, so a reference or pointer can be created. So as already said, you can create a pointer of the type. Okay, right. So all the pure virtual must be overridden in the derived class. Okay, can be used to create generic extensible libraries. Okay, so you may think like what is the need of abstract class? See, when I'm not creating the body, when I do not have the definition of it, then why I need the base class? Sorry, when I why I need the pure virtual function? So generally, okay, it is used when you want to create a template means I don't refer to the template keyword. Okay, so basically you want to create a generic framework or something in which, okay, say for example, I'll give an example. Let us assume there is a application. Okay, so we create a number of application. So an application may have some life cycle methods like on open, on close, on window open, something like that. Okay, so generally there can be a base class for that in which all these methods like on open, on close, on window open, etc., all these are declared in the base class, and it may be pure virtual. Okay, so the base class pure virtual is just providing the guidelines for all the derived classes, so that all these derived classes, or that is the application, will be of same base type application. Okay, and hence it is possible to shift between implementations, okay, in the runtime. Okay, So for all these reasons, the abstract class is important. The abstract class is useful. Okay, right. It creates a kind of a framework. Okay, right, in which it sets the guidelines by providing the declaration of the method, and it gives the derived classes to implement them. Okay, so there can be multiple derived classes which implement them, and it is possible to shift between those implementations in the runtime. Okay, right. Fine. So that's about abstract class. Let us see if we have, I think we do not have example. If not, maybe we can try to write one example. Okay, fine. Okay, so let us have a backup of this, and then we can change it. Okay, right. So, okay. So how many pure virtual functions we have means we can have multiple pure virtual functions. Okay, one or more, or zero or more. Okay, right. Okay. So my aim is I want to make this as pure virtual. So do we need to make any change here? May or may not be, depends on our requirement. You want to leave it as a normal method, or you want to make it virtual, or you want to make it pure virtual. It's up to the requirement. Okay, right. So, okay, let me not touch it. Let me keep it as non-virtual itself. Fine. So what we can do is, let us try to create. Okay, let me. Okay, see the name is drive one. Let me create one more drive two. Okay, and so which is the pure virtual function here? Show. So I'll say drive one class display, and here I'll say drive one class show, and here I'll say drive two class display, and here I'll say drive two class show. Okay, right. So definitely I cannot create an object of base. Okay, in case you try to, you will get a compiler error. So let me remove this statement. And okay, so why don't we do something different here? So instead of taking this object, let us try to dynamically create the object. Okay, right. So I have a base pointer p pointer to the base class. So let me try to create an object of uh, derived one. Okay, and here let me try to create an object of uh, new derived. Okay, right. Of course, here again, it may be possible to shift to this. Okay, so it is possible to, okay, change the binding between the method call and the actual method which gets invoked, okay, in the runtime. Okay, right. So the code looks okay. Uh, I don't think this is required. So because you are doing dynamically, okay. So let us review the code once more. So I have the base class, I have the derived class once more. Okay, and okay, looks fine. Okay, I think since C++ is a case sensitive language, we need to have of, okay, small letter try. Okay, fine. So let me execute it. Okay, before I execute, let me rename it so that it will be easy to refer it again. Okay, so let me rename it to abstract class. And one more thing is there is no abstract keyword in C++, but in Java it is there. Okay, right. An abstract class is a class which has virtual methods. Okay, right. Okay, so if you see here, I think I should have changed the message here. So P is pointing to drive one. So as you can see here, of course, base class display, because it doesn't participate in inheritance. So here, see, this is drive one class show, drive one class show. Okay. So here we try to create the object dynamically rather than, okay, uh, on the stack. So basically, this object is created on the heap segment, okay, not on the stack segment. If you create like this, drive one, okay, D, okay, here the object D is created on the stack, okay, but here, okay, it's created on the heap. So which one? It depends on your requirement. If it is on the stack, definitely that gets destroyed by the time the method returns. When the method is returning, it gets destroyed. But if it is this one, okay, it will be available beyond that as well. Okay, and of course, it's our responsibility to delete it by using delete space P. Okay, right, where P is the pointer to the object. Right, fine. So that's about abstract class. Now let us discuss exceptions. Okay, okay. What is an exception? Means an exception is a runtime error. Okay. See, originally exceptions were not part of C++. Eventually, in the later, in the subsequent releases, this exception handling feature has been added. Okay. But exception handling feature is very good, and it helps the developers by uh, it helps developer making them to write, okay, compact size of code, because you need not handle, okay, each and every runtime error. I mean, you may need to handle it, but you may not need to write huge code for that. Okay, right. So what is an exception? First of all, means an exception is a runtime error. Okay, fine. See, you write a program that gets compiled. If there are any compilation problems, syntax problems, okay, definitely the compiler will give the error and the developer need to correct it. Okay, so those are compile time errors. But there are some runtime errors, okay, which cannot be predicted by the compiler. Okay, say very simple. Say you are trying to connect to a remote server, or you are trying to connect to a database, and we have provided some IP address of the database or remote server and some username password credentials. Can the compiler know that those username password is right? Even if compiler knows, maybe that username password may get changed later. Okay, so compiler cannot validate those. Okay, and hence, okay, that is known only in the runtime. And maybe if the credentials are wrong or if the IP address is not available, what happens? A runtime error occurs. Okay, right. So generally, what we are doing in C language, whenever we are calling a method, okay, and something goes wrong in that method. Say you are trying to connect to a database and you are not able to connect for whatever reason. Maybe we were returning -1, -2, whatever to tell that, or maybe we were returning null, okay, to tell the caller that, okay, the connection to the database failed. Okay, so whenever you make a method call, you had to use lot of if checks. Okay, so how many calls you make, how many ifs you need to check it with, how many if, else if, etc. If one error, this error, that error, okay, multiple errors, okay, and okay, right, and you had to return that from the other method, from the called method, okay. But by using exception handling, we are relieved, okay, by not depending upon all these if checks, returning, etc. Okay, right. So, how a programmer can use this exception handling means there are few keywords provided by C++ compiler which can be used. So the programmer job is very easy. The programmer has to use that keyword, and if an exception occurs, the control goes to the catch block. So maybe in the catch block, maybe the developer may display a message to the user, or maybe send a mail to the support team, or maybe do something else. It's up to the requirement. Okay, right. So try, catch, throw. Okay, so these are the keywords which are provided by C++ compiler. Okay, right. So due to exception handling, the handling of runtime errors is made easy. Okay, so the developer need to focus mostly on the business logic, not on the bookmarking information. Just checking if it is successful, do this. If it is not successful, because of so and so error. If it's not successful of so and so error, so we need not check all those. Okay, whenever there is a error, the control will directly, okay, the method gets returned and the control goes to the catch block. Okay, right, fine. So you can just take a read, okay, okay, read of all these things which, okay. And one more advantage of exception handling is, see, definitely we need to write less code of less piece of code, okay. And one more advantage is the readability of the code is better. That means wherever an exception occurs, there is a possibility of occurring the exception that is bundled into a try block. And wherever you are handling it, that is put in one or more multiple catch blocks. So readability wise also it is better. Okay, right. So tomorrow you just want to handle it, one more handle, then you can have catch. Okay, and for every method call, you need not have a separate try catch. Okay, you can have it collectively based on the requirement, one try catch for multiple calls. Okay, and one more thing is inside try catch you can't have the entire class code and all. Generally inside a method we use try catch. Okay, right. So so let us see an example, then uh, this will make more sense. Okay, let's go to the basic exception. Okay, fine. So as seen here, okay, here the main method execution starts. Okay, and basically I am doing this here. Okay, fine. So similarly, here I'm just doing very minimal check with 0. Okay, so similarly, you can have a lot of code here. Okay, maybe you can have method calls or whichever. Okay, right. And it is not that the throw need to be directly here. It can be inside any other method call. We will see some examples for that. Okay, basically what I'm trying to emphasize is whatever piece of code may cause a runtime error that need to be bundled in the try block, as you can see here. Okay, and in the catch, see, whenever an exception is thrown here, okay, the all this code is not executed. Okay, immediately the control comes to the catch block. Okay, right. So here we have only one catch block. Similarly, there can be multiple catch blocks. We'll see such examples in next few minutes. Okay, So, okay, let us try to execute. I mean, just to make it more clear, let me try to put one more C out here, saying like C out, okay, in if, sorry, in try block, okay, right. So this is a try block. It starts here, it ends here, okay. So try block is always followed with the catch block, one or more catch blocks, okay, right. So I have ended here. Then let me have one C out here saying, okay, before throw, okay, right. So let me have one more here, C out, okay, after throw, okay, fine. And you can have, right, C out, end of try block, okay, right. So it's very important to understand the flow of the try catch when exception occurs. Okay, see, and when it doesn't occur. And let us assume no exception has occurred. When, okay, in the try block, in that case, it doesn't go to the catch block. Okay, right. So only when there is a runtime error to handle it, it goes to the corresponding catch. Otherwise, it does not. Okay, right. Okay. So let me try to. Okay, as you can see here, of course, we are getting the first line. After that, there is in try block. Okay, but in try block, okay, after that, we have before throw. We do not have after throw. We do not have end of try block. Okay, right. And actually, it is supposed to, actually, it is supposed to go to catch. Okay, right. Let us, the control is supposed to go here inside catch, because here we are throwing a var. The var is of type int, so we are it is supposed to go here. Okay, right. Let us try to rebuild and check it. Yeah, yes. So looks like it was not built properly earlier. So as you can see here, the control is coming to the catch block. Okay, right. So let us right. And one more point is one try can have multiple catch blocks. Okay, say for example there is one more catch block, and the type I expect is, say for example, float. Okay, and let me say FD, right. I'll say C out. Okay, I'll just put something like float exception. Okay, right, just to uh, check if this gets executed. Okay, just to check the flow. So as you can see here, okay, the control goes here. But by any chance, if this is a float, then the control goes to the uh, okay, uh, catch which float. Okay, So the matching one, it depends upon the type, okay, of which data type is being thrown, right? So that is about basic exception. We had seen what is a exception, what are the keywords involved with exception, try and catch and throw, and we had seen the flow of the, okay, right, flow of the program. Fine. Okay. And when you are hearing this exception for the first time, it may take some time to get comfortable. Okay, there are some examples here. Maybe you can try to check some examples right on the net as well. Okay, so it may take some time to get in-depth knowledge. Okay, so that's quite natural. Okay, right, fine. Next is, so there is a more material here, reading material. So you may read it. Okay, right. So here I just try to explain the concept. So here it's a try block. Got it. So fine. If there is no error, it continues the processing. If there is an error, then it will go to the matching catch. Okay, right. So how you want to handle it's up to you. Do you want to shut down the program, or you want to show the message to the user, or you want to send a mail to the uh, support team? It's up to you. Okay, right. Next, fine. So so some more things just wanted to tell about regarding exceptions. So one try can have multiple catches. Okay, that is one point. And the other point is, here, if you see in our example, here we are trying to throw the primitive type. There is no rule that it need to be of primitive type. It can be of user defined type. That means you can throw the object also. Okay. So in case you have multiple, uh, I mean multiple data item, maybe that can be bundled into a exception object or which one, and it cannot, or okay, or something related, and you can throw it. Okay, right. It's not necessary that it need to be of primitive type. Okay, fine, right. And one more thing is, see, in some cases, you may not be interested to catch. Say, for example, whenever you are connecting to database, you may get username password exception. You may get some SQL syntax exception. You may get some other exception. Okay, so you are not interested to catch each and every individual exception. Okay, in that case, you can have something like this: catch all exception. I think we have an example. Okay, fine. So a catch all exception looks something like this. Okay, it will be like this. Fine. And see out, I'll say this is catch all exception. Okay, fine. So this is catch all exception. So there is no rule that there need to be multiple catches. So it can be like this also. That means all the exception. If it is like this, that means for this specific exception, the control goes into these catch blocks. If there is any other exception apart from these two, okay, then you want to behave in the same way, then you can have catch all, okay, exception like this. So this is the syntax which we need to remember for catch all. There are three dots, which is called ellipsis operator. Okay, so that is about exception handling. Let us see some more examples for this. Okay, okay. So here the snippet says about catch all. Okay, and one more thing is we can have nested try catch. That means I'll just try to write the code. Okay, here. Okay, just to understand the flow. Okay, so let us name it as nested try catch. So dot cpp. Okay, right. So I'll just try to write the pseudocode, not the complete one. Okay, say for example, of course I'm not writing all those in main. Let us have it to avoid confusion. Okay, all right, this is just a pseudocode, not that comparable code. Okay, right. Say let us assume you have a try. Okay, and you have some statement here. Fine, and some other statement here. Okay, right, it can be statement, method call. Okay, anything, whichever. And here I can have another try. Okay, and I can have catch. Okay, so this catch is associated with, okay, you can have one or more catches here. Basically this catch is associated with this try. Okay, so there can be multiple catch here as well. So here you have some business logic, here you have some business logic, here you have the handling part of the, okay, this inner try, exception occurring in inner try. Here again you have business logic. Okay, right. Again you have business logic. So if any exception occurs in this piece of code and in this piece of code, got it right, then the control will come to the outer catch or any of the outer catch matching ones. Okay, right. So this is the skeleton of the uh, right try catch. And in most of the examples you can see that the try catch is used only in the main method, but not necessarily. It can be in any of the user defined methods. Okay, all right. So we have been writing different methods in different classes, like calculating area and etc. etc. So you can have the try catch in them as well. Okay, right. So so like that is about nested try catch. Okay, right. And one more thing is inside catch here as well you can have try catch, but I mean it's not required in the normal scenarios. Okay, fine. Now fine. And one more thing is there is something called exception specification. So until now we know there is a try block, there is a catch block, one or more catch blocks. See, whenever an exception may occur in a method, okay, there is no rule that you need to handle then and there. Okay, so if an exception is occurring there and you are trying to handle there in that method itself, it may not be of that use. Okay, right, because you may do that using even normal if check also. Okay, right. So whenever, see, this is a declaration of a method. This piece of code is the declaration of the method. So here it doesn't return anything. This is the name of the function, and this is the interesting part for us. So what it says is this function may throw an exception, okay, of type char or int. Okay, right. So that means this method is not handling that exception. Whichever exception is being thrown by this inside the body of this method, okay, right? And you are not handling there by using try catch. You are just using throw there, okay? And it is the responsibility of the callers of this method to use try catch and call that method. See, if you observe closely here, I'm using this method and I'm using try and catch. Can you see it? Okay. And if you see the implementation of this a function, okay, right? Okay, good. We have the implementation of a function. Okay. If you see here, we are throwing C, here we are throwing I. We do not have try and catch here. Okay, fine. You can just take a look at the code. So basically, the bottom line is it's not necessary that you need to handle there and then. Okay, fine. So which one you think is preferable? Handling the exception then and there in the method, or the exception handling by the caller? Means fine. Let us assume you developed a framework. A framework is nothing but it's a set of classes. Okay. Let us assume you developed a small framework which is used for easily connecting to the database and you released in the market. So your framework is used by a number of developers, let us assume. Okay. So one developer wants to display his own message. He wants to say like failed to connection to database. And one more developer wants to display his own message, maybe in different language, or maybe some other in different human language. Okay. Some other developer they want to display it in their own. Okay. So you can give that flexibility only when you are throwing the exception and letting that exception, okay, be handled by the caller of that method. Okay, all right. So it's not that each and every exception you need to give the chance to the caller. Okay, wherever you feel it is appropriate. Okay, all right, right. So there is a keyword throws in Java. Okay, to specify the exception, the method declaration, but in C++, throw is used for that as well. Okay, so throw is used to actually throw an exception. Okay, and for specifying that also. Okay, see, this is an action which executes and throws an exception, but this is just a specification. Okay, which just shows that this method may throw an exception during the runtime, so that whoever is calling that method, it is their responsibility to try catch and handle it and or further throws. Next, one more thing. Fine. So in exceptions, we had seen what is a basic exception, what are the keywords, and what is catch-all exception, multiple catch blocks, and throwing the exception across methods. Okay, and throw as a specification to a method, and catch-all exception, and nested try catch. Okay, uh, right. So these are the concepts we discussed. Fine. And one more thing I want to tell is about rethrowing an exception. Okay, right. So let us see what is that and how how that will be useful for us. Okay, right. So we have an example. Okay. So here we have main method. Fine. Okay. And here we are calling some method exception function. So the control execution control goes here. Here, okay, some exception is thrown. We are throwing it unconditionally. That may not be right in the production code. Okay, in the real project, you need to check some condition and then throw it. Okay, right. Anyway, we just want to see the working of it, so that's why we are directly throwing. Okay, right. So here we are throwing it. Whenever we are throwing it, we know that the control goes to the matching catch. Okay, so definitely it goes here. Here, what I'm doing is I'm further using throw. Okay, that means you are handling it partially here. Okay, and you further want to give the handling chance to the callers of this method. Got it? So you are further throwing. Okay, so the bottom line is, with the throw keyword you can create and throw an exception, you can rethrow an exception, and you can use throw keyword even to specify along with the method declaration. Okay, so throw performs three different roles. Okay, this is the most frequently used. Okay, of course with method declaration also using throw. Okay, that is also quite frequent. Fine. Okay, so right, let us execute it. So if you want to see uh, the flow of execution, you may put logs, that is cout statements, or you can use the debugger. Okay, fine. So all these concepts are available in Java. Of course, the exception handling is still better in Java compared to C++. Okay, so you will learn this concept there as well, and there are numerous examples provided in Java and material. Okay, so that will make you more confident. Okay, however, this will help you as an introduction to exception, like what is runtime error and etc. Okay, all right. Now, so let us. So looks like we have a error. Okay, I think it's because of this one. So there is object file and there is a duplicate main method. Okay, that is the. Right. So can just try to verify the flow. Okay, yourself. So basically here we are calling exception function. So the control goes here, and again it's being thrown. If you write any statement here, it doesn't get executed because it's being thrown from here. So the control comes here. Again it's being thrown from here. Okay. So the control comes here, and if you write any other code here, it doesn't get executed. Immediately the control goes to the catch block. So there is no rule that you have to use always throw here. Even it can be a method which internally throws an exception. Okay. So here you may call a method that may call some other method that may call some other method. So maybe the method which is nested in internally that may throw an exception. And as a result, you may want to handle this here. Okay. There is an interesting term for that which is called stack unwinding. Okay. Right. Fine. So basically, you need not return. If you just throw the exception, the methods get returned. Okay, until there is a try catch. Fine. Okay. So that's about exceptions. Okay.